with the Danish ESA astronaut, Andreas Mogensen. Welcome to you, Andreas.
Thank you.
So we were very happy you could take the time out of your busy schedule. You're vacationing in Denmark at the moment, right?
Yeah, well, I think technically I've been on vacation, but I'm technically here for work, so I'm glad it fit into the schedule.
Great. So we're glad you could join us here at the studio at the European Space Agency Business Incubation Center, Denmark. So my name is Sune, and I'm the manager of ESA BIC Denmark. Today's fireside chat is part of our pre-incubation acceleration program called Launchpad. And this is a program where we try to support aspiring space entrepreneurs to achieve, let's say, commercial escape velocity for their startups. So among the audience today in this fireside chat, we have a number of ambitious, talented, and also innovative space entrepreneurs with the ambition to build successful startups. So I don't know, can you turn on your cameras, all of you space entrepreneurs, and greet Andreas in the studio? Just give him a good wave. You need to turn on your cameras. Okay, great. Good to see you. So the topic for today's fireside chat is what can space entrepreneurs learn from astronauts? This may seem like a peculiar question, but the contention here is that despite being very different career paths, there are perhaps also similarities between being an astronaut and being a space entrepreneur or an entrepreneur in general. So, for instance, there's a lot of issues regarding motivating yourself in the face of obstacles, venturing into unknown terrain, taking calculated risks, of course, also learning from inevitable mistakes, and preparing for contingencies because you don't know what is going to happen. So today we will talk to Andreas about his training and experiences as an astronaut, and also how they can be related to being a space entrepreneur. And we will also talk to Andreas about where he sees interesting opportunities in the landscape of space technology and commercial space when looking across the landscape from his vantage point in Houston. So this is an interactive fireside chat, and this means that you will also, as participants, audience, will have the opportunity to ask questions to Andreas during the chat. And you can do that by using the chat function in Zoom. And feel free to ask questions anytime during the chat. So, Andreas, it's been 6 years since you went to space. What kind of memories most vivid? You went to this space station, right, in 2015?
Yeah, the International Space Station. I was launched on the 2nd of September, so it's 2 weeks away from being 6 years ago, as you said. And thinking back, it's almost like a dream because it was such an intense period. It was 10 days from launch until landing, and those 10 days were packed with all sorts of activities. And because I was only there for 10 days, it was easier to pack my schedule with activities. If you're up there for 6 months, you need to maintain motivation, and so you have you still work hard, but it's a more relaxed schedule. Yeah. But for me, it was more of a sprint than a marathon. So yeah, looking back, most of the days have sort of blended into each other, and it's almost like a dream. But certainly, I have a lot of incredible memories. One of the highlights is seeing the Earth from space, and it's what all astronauts remark upon when they get back to the Earth, because it is very, very special to see the Earth from space. Yeah. I mean, from the space station, it only takes an hour and a half to fly once around the whole Earth, and so an hour and a half by the window, and you see most of the Earth from the space station, and it's beautiful, especially when you're on the sunlit side. You see the blue oceans, the green continents, the the orange, almost red color of the deserts in North Africa. And then you transition on to the night side of the Earth, and then you suddenly see all the lights from the cities light up the sky. And so that's certainly one of the highlights. Mm-hmm. But everything about the space station is very unique. It's a world-class laboratory where we do scientific research, we do technology development. And so the work itself is fascinating. Free time is fascinating because you're looking out the window or you're just having fun in weightlessness. So it's all of it is an incredible experience.
Did you have time to take it in, that like enjoy the experience as well? Despite your busy schedule?
Yeah, I mean, you enjoy the small moments when you're eating or looking out the window. Certainly, I didn't sleep as much as I normally do because I didn't want to waste time in some way.
Yeah. And looking back at this as a human being, did it leave any mark on you, like seeing the Earth, or I mean, what was the lasting effect on you as a human being going to space, if any?
I would say sort of the sense that we're all connected, that the Earth is one planet. We're not, is it 200 odd countries, but we are one planet that we all share. And if we could learn to live side by side without conflict, then a lot of our challenges would disappear, because a lot of our challenges are self-inflicted. It's because we can't agree on how to share resources, how to share water. We draw artificial lines in the ground and say, this is a separation of two countries. And when you see it from outer space, you don't see borders between countries. And on the day side of the Earth, you don't even see signs of humans. It's you just see this very, very peaceful planet that, for all intents and purposes, could be uninhabited, devoid of humans. It's only when you get to the night side of the Earth that you see the lights from the cities that you become aware that there's a lot of people living here. But on the day side, it's
so we should send humanity, or at least our kids, into space so that they can get this sense of one united humanity.
That's one of the ideas behind space tourism, is to make more people able to get this overview effect. So hopefully space tourism will be more than just a joyride for rich people. Hopefully it'll help to make people more aware of the Earth.
So looking forward, what is in the cards for you in terms of returning to space? Could you elaborate a little bit on that?
So I hope to return to space. You asked just previously what's one of the effects of going to space. One of the effects is that you want to go back, or at least I want to go back, because it's such an incredible place. But I hope to go back in the next 2 to 3 years. And most likely it'll be a mission back to the International Space Station. Hopefully a half-year-long mission.
So more free time. That's good.
More free time, more time to really get a sense of what it's like to live in weightlessness in space.
And we discussed this over lunch. I mean, how quickly do you get used to being weightless? How quickly do you adapt to that state of bodily state?
So to the sensation of being weightless, very, very quickly. It's almost a natural sense of being, because it doesn't require energy, it doesn't require muscles, and it's the ultimate sense of freedom. It's just incredibly easy to move. You really have a sense of freedom. There's a small little push, and then you're gliding off down the space station. But to properly live in weightlessness takes a bit of time to learn. So you need to adapt. You need to learn how to move in an efficient manner. And I certainly didn't learn that in the 10 days that I was there. You tend to, when you get up there, to begin with, you tend to be a little bit like a rock climber. You grab onto a handrail and you push off, and then you grab the next one. but it means you can't have anything in your hands. And so when you see astronauts to begin with, they typically have their laptop computer and their camera sandwiched between their legs, and then they're using their hands and arms to move, which is kind of inefficient. So after a while, after a few months, you begin to learn how to use your feet and your toes to control movement, and then you can carry things in your hands. Another thing that I thought was interesting and frustrating as well was, you use a lot of Velcro, and so, for example, on the back of our iPads, we have a little piece of Velcro, and then you can Velcro it onto your pants, and the idea is that it just follows you. But my movements were always too abrupt, so whenever I tried to turn around, the iPad would go flying off in a different direction, and I was fascinated with the other astronauts, how they could move so gracefully, exactly, and the iPad would just stay there the whole day.
So next time we will see you ballet dancing in space, right?
Maybe.
So looking back, you were selected around 2010, right? Or when was it?
2009 I started.
Okay. So you've been first training, like basic training as an astronaut, and then mission-specific training, then going into space. Looking back at the training and your experiences, what were the hardest obstacles you've had to overcome, physical, mentally, along the last 10 years or so in your line of work?
So certainly one of the challenges is the diverse set of skills that we have to learn. It's when you're selected as an astronaut, you start basic training, and then, as you said, after that you have mission-specific training. And those two periods, it's almost like being back in school. And once you're 30, it's hard to go back to school. But we sit, I mean, essentially like in school, we sit, in a classroom, and we have a teacher, and 6 to 8 hours a day we have lessons. Most of it is technical training on all of the different systems on board the International Space Station, everything from the computer systems to the life support systems to the communication systems. We have to learn not only how to use them, but also how to repair them in case anything goes wrong, because even though we're doing science and technology development, if anything goes wrong, we also have to be the plumber. You don't often think about it, but if the toilet breaks down, you don't have a whole lot of days to fix the toilet until it becomes a big problem. And so things like that we have to learn as well. And then, of course, there's the practical skills of learning how to control our space station robotic arm. This is our 17-meter long robotic arm that we use on the outside of the space station to make repairs, to deploy new experiments, to catch some of the unmanned cargo vehicles that come up. We actually use a robotic arm to catch them and to berth them to the space station.
And so, were there any one specific area which was especially challenging for you? I mean, learning Russian or whatever during the course of the training, or was it like the breadth of the array of skills you had to acquire?
One challenge is the breadth of skills, but specifically for me, learning Russian was probably the most difficult thing, because I'm more of a science and maths guy. I like numbers, and learning to speak Russian was challenging. And
I guess this whole training process must have been a challenge in general. I mean, what drives you? I mean, what is your motivation when you are faced with these kind of challenges or obstacles?
Yeah, that's a good question. I never, to me, it's so self-evident that going into space is the biggest motivation. It's what I've always wanted. I can't imagine anything more exciting or rewarding, because it combines the two aspects which I find the most fascinating in my life. One is science and technology. I'm fascinated by the scientific exploration of the universe, understanding nature and the laws of nature, understanding how everything came to exist and how it's evolved. And then at the same time, I'm also fascinated by the personal journey, the voyage of discovery, the adventure that it is to go into space. And these two things combined into a single job for me is what motivates me.
Yeah. So I looked up some numbers just concerning the latest application campaign that ESA solicited for new astronaut corps, and 22,000 applicants have applied, and they will select a team of 4 to 6 astronauts eventually. So this is kind of the same odds as for an entrepreneur to make a unicorn, right? A unicorn startup. So the odds are overwhelmingly against you in a sense. So. Yeah. But you have the confidence, I mean, to apply and of course get selected. But I mean, what did you bring to the table in that sense from a mental point of view?
Well, first of all, if you don't take the chance, you're never going to succeed, right? So that's always been sort of my starting point. Is that you've got to take that first step, otherwise you won't get anywhere. And then my sort of philosophy, even though I'd never really thought of it as philosophy, it's just you could say I guess you could call it philosophy. I've always just thought, if others can do it, there's no reason why I can't do it. Not because I have any sort of skills or abilities, but if other people can do something, then why shouldn't I be able to do it? If I just approach it methodically and I'm willing to work hard. I mean, it requires hard work, but if I'm motivated and then I'm willing to put in the hard work, then why shouldn't I be able to achieve it? That's always kind of been my going in position, no matter what I've done. If it's skydiving, or if it's deciding to do a PhD, all these different activities, I always thought, well, if others can do it, I can do it as well. But you could say, to begin with, in the application process, there's so many people that apply that I didn't think a whole lot about it, because I realized that the odds were so small that it was very easy to sort of to ignore the pressure and the stress, and then just kind of focus on that one step at a time. The first round of selection, and the second round, and the third round. And it wasn't until we were 20 candidates left that I started to feel the stress, because suddenly
there was a chance.
Suddenly there was a realistic opportunity that it could happen. And that's when I started, finding it difficult to concentrate about anything else.
So as these questions are coming in, that's great. Just a quick remark or additional question, follow-up question. I mean, that confidence, that ambition, that drive, is that something that you just got as a birth gift, or is there something like mental training for astronauts? I mean, how do you work with the motivation and also like the risk-taking part of being an astronaut? How do you address the psychological side of being an astronaut?
Yeah, that's a good question. I mean, you come in with it with a certain level, but through our training, a lot of our training is focused on what we call human behavior and performance. So learning how to get the maximum performance in a given situation, and not just from you personally, but as a team, because everything we do is typically as a team on board the space station. We're typically at the moment 7 people. And so you're part of this team. How do you communicate in a manner that fosters teamwork, that builds bridges rather than builds walls? But the psychological part of it, the risk is, I don't know. I think that's something personal. It's for me at least, it's related to the reward, right? The reward has to be there in order for me to take the risk. And for me, the reward of going, not just personally going into space, but being part of shaping the future, because I think space exploration is about the future. It's about what kind of society do we want? Where do we see ourselves going? You've taken those first steps towards the future through space exploration and developing space infrastructure, a space industry. So being part of that process for me is worth the risk.
All right, so I think we'll take a question from the audience. Is that the total number of questions? So we already addressed the first couple of questions. So there's a question about space biology. This is a specific project in this program. Can you tell us more about space biology issues in space? For example, do you take any specific medicine to prevent the onset of space-related diseases?
Yeah, that's a good question. The only medication that I'm aware of that astronauts sometimes take is medication against seasickness, motion sickness, because we do have what we call space adaptation sickness. When you go into space and you're weightless, your sense of balance is no longer working, and so some astronauts, even a majority of astronauts, feel some kind of motion sickness, and so anti-nausea medication is something we take. But otherwise, we don't take medication. Typically, we don't take medication to strengthen our bones, even though that's something you might imagine, because there are a lot of detrimental effects from being weightless. The only way we know how to counteract some of those detrimental effects is through exercise. So it's actually a requirement that you exercise 2 hours every single day when you're in space, in order to prevent muscle loss and bone density loss.
And can you disclose whether you had to take any nausea-preventing medicine?
I mean, I took I took a pill before launch, just to be on the safe side.
No problems.
No, I had no problems, luckily. But I can tell you, I mean, I talked with some of my colleagues on board the space station a week before I launched, and they said, remember to bring vomit bags because we've run out.
Okay, good advice.
So it's very, very individual.
Yeah. A follow-up question to the space biology angle. So where do you think that the field of space biology should concentrate its effort? Human health and long-term missions, food production, others? What could be the most interesting area to focus on?
Oh, that's a good question.
Depends on whether we're going to Mars or not.
Yeah, I mean, so the main problems is the deterioration of your muscles and bones, but we can counteract that with exercise. We see changes in our visionary field. We think it has to do with a change in pressure in the head. We see changes to our immune system. And then if we're talking about a mission to Mars, the biggest challenge, I think, will probably be the amount of radiation that we encounter. I'm an engineer, so I like to think that there are engineering solutions to most of these problems rather than medical solutions. Also because it's, back in the early days, at the start of the age of jet aircraft, there was also this talk, if you fly high enough, you can suffer from lack of oxygen. And so there was the medical community, they wanted to invent a pill that you could take so that you didn't need as much oxygen. And engineers said, well, why don't we just give them an oxygen mask?
Seems like a quicker way.
Yeah.
All right, so let's move on with the questions. A lot of good questions are coming in. We already addressed a couple of those. Some pressing, urgent challenges relating to space that you would urge entrepreneurs to tackle?
I mean, one of the big problems we face right now is the challenge of space debris. We have currently, and this is just from memory, so I could be wrong, but I think we currently have somewhere between 1,500 and 2,000 satellites in orbit about the Earth. And when we look at some of the plans from, SpaceX with their Starlink systems, OneWeb, Facebook, they're talking about launching a network of 10 to 20,000 satellites. And so we're really talking about an increase in 1 or 2 orders of magnitudes in the number of satellites orbiting the Earth. And so the need to ensure safety or decrease the risk of collision, and then also removing satellites from orbit that are no longer working is a big challenge, and something a lot of people are working on.
So you have a unique vantage point in Houston, and you're well connected in the space community. When you look across the landscape, what kind of, in more general sense, mega trends or significant developments do you see, both in the technological area and also commercially? We all know Elon Musk is building his Starliner, right, or is it Starship? Sorry. But how does the landscape look for you? What are the most significant peaks and valleys?
Well, so the big, well, at least for me, the big excitement at the moment is our return to the moon. Mm-hmm. So NASA and ESA are working together to return humans to the moon, and not just to the surface, but also to orbit about the moon, where we're building a smaller space station called Gateway. And then at the same time, we're sending robotic missions to Mars in order to prepare for one day sending humans to Mars. And so we have a vision of, well, it's more than a vision, a plan to go to the moon, and then a vision to go to Mars. And I think this is incredibly exciting from my perspective. Some of the technological challenges and some of the opportunities with these missions are primarily in the fields of in situ resource utilization. So using resources on the moon and Mars to make the missions more sustainable, because that really is one of the challenges. It's the amount of resources to support humans on the moon and Mars that really makes it challenging and very, very expensive. And so the more you can use resources on the moon and Mars to support your mission, the better. And so a lot of people, well, not a lot of people, but there are ideas for using, for example, the soil on the moon in additive manufacturing or 3D printers to produce parts, and also to use deposits of ice on the moon, or even the atmosphere of Mars, to produce fuel and oxygen and water. But that's far out. I mean, more near term, what I think is very exciting is the role that satellite networks can play in improving life on Earth. And that's everything from communication satellites to navigation satellites, but especially Earth observation satellites.
So just focusing on, let's say, the orbital part of the commercial space. So you just mentioned before we sat down here that actually SpaceX has just sold an entire capsule on commercial terms for a billionaire. So also see Branson and Bezos doing stuff, hurling themselves into space. Space tourism is taking off, it seems, right? What other kinds of orbital commercial activities do you see taking off within the next 5 to 10 years?
I mean, my interest in space tourism is more along the lines of reducing launch costs. Space tourism in itself is fine, especially if it gives more people a sense of the overview effect that we talked about earlier. But really, for me, the main motivation of hoping that these space tourist companies are successful is their ability to drive down launch costs, because that is the biggest hurdle for space activities in general. It was, from what I understand, it was also one of the driving factors for NASA to go to a more commercial partnership with companies like SpaceX, in the hopes that they could be innovative, that they would be interested in investing some of their own resources in the development of their technology in order to reduce launch costs. And what we've seen so far, of course, it's still early days, but what we've seen so far is, SpaceX being able to capture a significant portion of the commercial launch market. So much so that a lot of other countries are now having to rethink their own launch industries,
including Europe.
Including Europe, that's right. And the Ariane 5 rocket, used to have more than 50% of at least the large the commercial communication satellite side of business. But certainly Europe has to rethink their launch industry as well.
So just to rephrase the question in a way, if you were among the participants today in the Launchpad program, what kind of space startup would you aim for? What would that space startup do?
I've always, it's a good question. I mean, certainly using data from satellites, especially from Earth observation satellites, I think there's a lot of potential in that. But my personal interest is more on the technology development side, and there where I'm very, very excited is the potential of miniaturization. I mean, we see these CubeSats or nano satellites being able to perform more and more detailed jobs in space, and so that's really, from my personal perspective, where a lot of the excitement is in miniaturization, in being able to develop and launch a satellite within 1 year, maybe, whereas traditionally it might have taken 10 years from concept to finally launch. Now with a small CubeSat or something on that size, we're talking within a year. And if you have a network of CubeSats, if one of them fails, well, it's not that big of a setback compared to if you have a multi-million-dollar satellite that fails.
But I guess more CubeSats also means more space debris.
It does, yeah.
So we have an interesting question about psychology. So let me just go back to that part again about risk. With all the training you have in emergencies, how do you deal with that mentally? How can you avoid thinking about risk all the time? And let me just follow up on that as well. So I guess in your training, you have a lot of training in contingencies, right? Scenarios. But how do you prepare yourself to deal with the unexpected, the freak accident, whatever that could be? So maybe that was two questions in one.
So sort of the starting point is to try to map out all the possible contingency scenarios, and then to come up with pre-planned responses. That's what we hope, certainly in mission control, that if something unexpected or something off-nominal happens, then we have almost a pre-packaged response, so that we don't have to improvise on the spot, because that's where you can often get into problems. So we try to beforehand, we try to map up all the different contingency scenarios, and then we train them. We before a spacewalk, before a launch, before any challenging situation, we'll have several simulations where there's an entire team dreaming up failure scenarios that we're unaware of, and then you take the mission control team, you put them in mission control, and then you start your simulation, and then along the way, this backroom team, they start injecting failures. And often the interesting thing is when you have several small failures on top of each other, because that's when you get these escalating effects where you see some of the interdependencies that you might not have thought of before. And so we do that to prepare. And of course, the astronauts, we do the same thing. We define the emergency scenarios. There are 3 main emergency scenarios on board the space station: a fire, a rapid depressurization, and then an ammonia leak. Those are the 3 main emergencies, and then we learn, we train, and learn instinctively how to react to them, so in order to minimize risk. But of course, there's situations, unexpected situations that occur, and then you hope that the training that you've gotten from all these other simulations will carry on, and then you'll be able to solve the problem.
So you didn't think about the risk launching to the space station or living on the space station, that at any time we may be hit by a meteorite or?
No, I even though there's an order of magnitude difference between space flight and aviation, I would compare it to flying. You get on board an aircraft, you understand that there's a risk. A lot of times it's an abstract risk, but there is nonetheless a risk. In civil aviation, the risk is minuscule. Nonetheless, we've had in the last couple of years, a few significant disasters. But most people don't, you don't think about it. Yeah, if you ask someone, they say, yeah, sure, there's a risk. But for me, it was the same. I was aware of the risk, but I didn't think about it. I trusted that if something occurred, I had the necessary training to respond.
All right. So I guess a follow-up question to the, let's say, the question about opportunities for entrepreneurs. So there's a participant asking here, a lot of business go to the big prime contractors. Where do you see niches that can be filled by smaller enterprise? Maybe especially thinking of like the Danish ecosystem, with the skills and resources that we have in Denmark, which we are not big on upstream activities, right?
Yeah, I mean, again, I would caution anyone to say, we're a small country, we can't do something. A good example of that is the Danish company GomSpace. Had you asked anyone 15, 20 years ago if that in Denmark would be building entire satellites, people would have said no, of course not. But yet we have a company in Denmark, at least one, building entire satellites. So I would caution anyone to write off upstream. I think the strength we have in Denmark is, we have very well educated people, people who have a solid background in science and technology development, and that's where I think we can compete, is in the production of like you say, niche components. So components that require that aren't necessarily mass produced, but that are limited in quantity, but require very, very high precision. If I had a specific, I would have a company building it.
Yeah, that's fair enough. So another, let's say,
but this is what's so fascinating about this, right? It's someone comes up with an idea, they start a company, and everyone else goes, "That was so obvious."
Looking back, for sure. Yeah, I don't think anyone would have believed what Elon Musk have been doing for the last 10 years if you've been asking them for 10 years ago. So yeah, I think that's hindsight is always obvious. Yeah. So just want to get back just for a moment to let's say the psychology of being an astronaut. So I guess you addressed this about the training, the contingency planning, the scenarios, and so on. There's a kind of similarity between being an astronaut and being an entrepreneur in the way that you have to learn from your mistakes. Can you elaborate a little bit about did it require for you a change of mindset to, that failure was actually on the path to success in a way?
Yeah, so one of the things I guess we've adopted, you could say, because aviation came before space, but this idea from aviation that you have debriefs and everyone is completely honest and you don't get judged, because that's the only way you really prevent the reoccurrence of the same mistake. So people in aviation and also among astronauts, we debrief after every activity, and then people say, well, I made this mistake and it could have had these consequences, and then everyone shares that information and learns.
And how do you in your training, or how did you in your training make sure that you learn from these mistakes? I mean, was it just up to yourself to kind of recognize that this won't work and then do it better a second time around, or what was that process like?
So I don't want to sound morbid, but I've always been fascinated by accident investigation reports. And so I worked for a couple of years in the oil industry on offshore rigs, and there as well, I would always read the accident reports, because it's very seldom one thing. It's typically always a series of events. And if one of those events hadn't occurred, the accident itself wouldn't occur. One person makes a mistake, but on top of that, there's a system failure, and then perhaps there's environmental conditions, and they all line up. The classic example is the Swiss cheese model, where all the holes have to line up. And understanding those series of events, I've always thought was very instructional in understanding, the work that I was involved in, and getting comfortable with assuming risk, because even though I might not be able to control the environmental conditions, at least I can be aware of them, and be aware that perhaps now there's a heightened sense, or there's a higher risk, and so I have to have a heightened sense of awareness in this situation. And of course, being human, I'm susceptible to making the same wrong assumptions, the same mistakes that other people are. So learning and seeing where other people made those mistakes, I think is very, very instructional and useful.
Have you ever felt stressed as an astronaut?
Stressed, certainly.
Like, this is on the limit of my capabilities, or this is really something that puts pressure mentally, physically?
Yeah, I think so. During some of the training events, I've participated in what we call analog missions, so missions underground and missions underwater, especially two NASA NEMO missions, where we live for up to a week in an underwater habitat, and we spend the days diving in hard helmets, and there's an incredible amount of focus on safety as well, because once you're at 20 meters depth for more than a couple of hours, your body is saturated with nitrogen, and you have to decompress before you go to the surface. Otherwise, in the worst case, you could die. And so certainly there, it's been pushing my limit, because it's it's not what we train for. We train to go to space.
Yes, sure.
And then we get a little bit of training to dive and to work underwater. But that certainly was because of the unusual circumstances, was challenging.
Yeah. There's a question about the balance between robotic and human exploration. How do you see that going forward? What will will robots, this is the cliche, will robots replace humans eventually in space exploration?
I don't think so. Before I became an astronaut, I was an engineer, and I always had a hard time understanding these either or questions, because for me, there are some things robots can do better than humans, but there are a lot of things humans can do better than robots. So for me, it was never either or. It's both. We need robots, we need humans. Especially when it comes to searching for life or signs of life. This is a very, very difficult task for a robot, simply because they don't have that intuition that humans do. There's also quite interesting operational limitations to robots, because robots, if we look at the Mars robots, the rovers, they're multi-billion-dollar machines, and so the last thing you want to do is to get it stuck in loose sand on the first day. And so operationally, there's a lot of restrictions on what it can do, because we want to operate it in a safe manner. We want to double check the surface in front of it. And so even though perhaps the robot is capable of more, it's so expensive that we restrict what we allow it to do in order to be safe. Which is why was it Opportunity, which was incredibly successful and spent, was it 12, 13, 14 years driving on Mars. In those 14 years, however many it was, I think it drove something like 30 kilometers, which over 14 years is not a lot. You give an astronaut a car on Mars and they could drive 30 kilometers in 2-3 days, 4 days maybe.
And I guess, I mean, you would, if you were offered the opportunity of going back to the moon, you would say yes, please. but
this is this is really exciting times. I think it's a lot of people aren't aware, but we are working to return humans to the moon now, not just to plant the flag, but actually in a sustainable way through the Gateway space station, and then several missions to the moon, perhaps even building some sort of habitation structure on the surface of the moon. This is going to be sort of our generation, or at least the next generation's big journey of discovery, I think.
Do you see the profiles of those astronauts going back to the moon, living there? Will they be different from the one that ESA and NASA are recruiting now?
I think that's going to be very similar to the astronauts that we recruit now, primarily because most missions to the International Space Station are 6 months in duration. And so there's been for many years now a focus on the psychological aspects of long duration spaceflight. And I think those same psychological aspects will play an important role on lunar and Mars missions. So I don't see a big difference going forward.
So there's a question from the audience, which I will rephrase, I guess. From an engineering standpoint, which is the coolest space exploration program that you know of, like globally?
From an engineering point of view,
technology-wise.
I mean, I'm still fascinated by SpaceX landing their first stage rockets on an unmanned ship out in the ocean. I mean, I think that's, as an engineer, that is just an incredible challenge to solve. I mean, you have the dynamics of the barge in the ocean, and then you have the rocket coming back and making a soft pinpoint landing. That's you could say now it's been solved. So what's the next challenge? But that certainly, I think, is fascinating. A similar challenge is on orbit repair and maintenance of old satellites, where perhaps even recovery of lost satellites, where you might have a satellite that's slowly tumbling, and then you want to approach and dock with it with another satellite. There's also some of that same complexity in guidance, navigation, and control as landing on a drone ship. So, I mean, I usually joke that when NASA is asked, or I remember President Bush Sr. in 1990, he said that we will be landed, humans will be on Mars in 30 years from now. So I usually joke that a manned mission to Mars is always 30 years ahead in the future. But how does the timeline look for you in terms of returning to the moon and returning to Mars? I mean, someone like Elon Musk is going really, really fast at the moment. I mean, so how does that roadmap look to you in terms of human space exploration? So, if it was up to just ESA and NASA, then the road is fairly clear. We're going to the moon, and my guess is we would be spending the next 10, 20 years exploring the moon and preparing the way for missions to Mars. And so, yeah, a Mars mission would be probably 20 years out, maybe 30 years in the future. And in this case, SpaceX is a little bit the joker, because Elon Musk has said that his goal is to send humans to Mars. And as you said, he's working very, very quickly. And so it's possible that, 5-10 years from now, he has a rocket and a capsule and a system ready to send humans to Mars. So who knows? But our focus at ESA and also at NASA is to return humans to the moon, and then at the same time have precursor robotic missions going to Mars to prepare for eventual humans. And so some of the precursor missions, one example is the NASA Perseverance rover, which includes a very interesting experiment to produce oxygen on Mars. So again, an example of what we talked about earlier called in situ resource utilization. And of course, oxygen is vital, not just for breathing, but it's also one of the two components of rocket fuel. So if you could produce oxygen on Mars from natural resources there, that's already a big step. So that's just one example of some of the precursor robotic missions that would enable humans in the future.
So it's not unthinkable that Elon Musk can put something on Mars, maybe a human being, within a decade or 2 decades. So what is your best guess? Is that unrealistic, or
I don't know.
Not correct to have any opinion on that?
I think predicting the future is
I mean, we couldn't predict where he would be today 10 years ago, right? So,
exactly. It's never, especially about the future, never say never. It's yeah.
So these guys out there and women, they are aiming for the sky, right? They want to fulfill their dream and realize the vision of building a startup. You are beginning of your 40s, right? Yeah, middle 40s, so ish. And you've already lived your childhood dream, right? And you'll be flying again, hopefully in 2 to 3 years.
Yeah.
Where do you go from here? I mean, what is left for you?
So I think what's lucky for me is that my dream, I mean, without really realizing it, my dream was never just to go to space and come back. My dream was to be part of the process of space exploration, not just as an astronaut, but also as an aerospace engineer before I became an astronaut. And so I don't really feel like I've achieved my dream, and even after my next flight, I don't necessarily think I'll feel like I've achieved my dream, because my dream is to continue. As I mentioned earlier, space for me is about the future. You know, how do we see our civilization, not just 20, 30 years from now, but 100 years from now, 500 years from now? I mean, it's, you know, who could have predicted the world we have today 100 years ago when aviation was taking off? I mean, if you look at the changes that have occurred in the last 100 years, and then you try to extrapolate out in the next 100 years, I find it almost impossible to predict that future. But I think part of that future is with space and space technology and all the benefits it brings to humans and our society. And so being part of that process of leading us towards our future is really my dream.
And then what is your vision for 2100? I mean, sea level will have been increasing so much that we cannot live in Denmark anymore. So, I mean,
I hope not.
What kind of future do you see in terms of inhabiting space or space exploration, space colonization, maybe?
I mean, when it comes to the state of the Earth, I hope that we have enough sense to take care of our planet. I mean, there is no backup. Even if we talk about colonization of Mars, I mean, that's not realistic in the sense of moving all of humanity to Mars. We have to take care of the Earth. I'm optimistic that we're smart enough to realize that, and we're also smart enough to develop the technologies to save the Earth from ourselves in a sense. In terms of space, I think what we'll see is, to begin with, research stations on the moon and research stations on Mars, where we can send scientists to for 6 months or a year at a time, in the same way that we today send scientists to the South Pole, to Antarctica, where they do research. Now, where we go from there, I mean, that all depends on what we find on the moon. Is there a business case for private companies? Can they extract resources, minerals on the moon, in order to support themselves and to have a business case. That I think will be the big question and the determining factor on what kind of future we end up with.
So that's a nice way of wrapping up our talk, Andreas. Thank you very much. We are out of time, so I hope that all of you out there got some inspiration and takeaways from this talk with Andreas. Yeah, so thank you once again for your time.
Oh, my pleasure.
For talking and inspiring our aspiring entrepreneurs. So, and goodbye from us in the Launchpad studio. Have a nice day.